Today we're going to be looking at section 10.3, Simplifying Radical Expressions. On example 1, we're told to use the product rule to multiply. We have the radical 3 times the radical 5, which is simply the square root of 15. The square root of 21 times the square root of x is the square root of 21x. The cube root of 4 times the cube root of 2 is the cube root of 8. Since we know 2 times 2 times 2 is 8, the cube root of 8 is simply 2. We have the square root of 2 divided by a times the square root of b divided by 3. We can rewrite that under one square root, and we have 2 divided by a times b divided by 3, which gives us the square root of 2b divided by 3a for our answer. On example 2, we use the quotient rule to simplify. We have the square root of 16/49, which we can write as the square root of 16 over the square root of 49. We know the square root of 16 is 4, and that the square root of 49 is 7. So we end up with 4/7. The next example is the square root of x divided by 9. We can write that as the square root of x over the square root of 9. We know the square root of 9 is 3, so we end up with our answer, the square root of x divided by 3. Our last example is the cubic root of 8 divided by 27. We can rewrite that as the cube root of 8 divided by the cube root of 27. The cube root of 8 is 2, and the cube root of 27 is 3, so we end up with a final answer of 2/3. On example 3, we're simplifying, and we're just going to break that square root of 50 down to the square root of 25 times 2. We know the square root of 25 is 5, so we can bring that out and we take it times the square root of 2, so our answer is simply 5 square root of 2. The next one is the cube root of 24, which we can break down to the cube root of 8 times 3, and further writing it as the cube root of 8 times the cube root of 3. We know the cube root of 8 is 2, so we can bring the 2 out and we take it times the cube root of 3 for our answer to be 2 times the cube root of 3. We have the square root of 25x cubed, which we can write as the square root of 25x squared times the square root of x. We know that 25x squared is a perfect squared, so we bring 5x out. We still have it times the square root of x. On example 4, we're asked to divide. We have the square root of 20 divided by the square root of 5. We can rewrite that all under one square root, and it's 20 divided by 5, which is simply the square root of 4, which we know is 2. On the next one, we can bring the 1/2 out. That's that imaginary 1 that sits up there. And we take it times the radical 50x divided by the radical 2, but we can write that under one square root. So we have the square root of 50x divided by 2, which we know is 25x. We still have that 1/2 hanging around outside. So we bring that 1/2 with us, and we have the square root of 25 we know is 5, so we bring the 5 out. The only thing we really can't do anything with is that square root of x. So 5 times 1/2 is 5/2, and we have it times the square root of x. On our last example, we have 7, so we have 7 we're bringing out front, and we're going to rewrite these two cubic functions under one cubic radical. So we have 48y to the fourth divided by 2y. 48 divided by 2 is 24, and y to the fourth divided by y is our y cubed. We still have that 7 hanging around out in front, and we look at that number 24, and 24 is 3 times 8, and the cube root of 8 is 2. So we have that 7 still hanging around, but we bring that 2 out. However, that only used the 8 times 3, so we still have 3 on the inside. However, that y cubed, when we have the cubic root of something cubed, it is just itself, so we bring a y out. We have now 7 times 2y, which we know is 14y, and we still have our cubic root of 3. Going on to something a little different, kind of interesting, the distance formula. It measures the distance between 2 points, and we label those as x1, y1 being the first point, and x2, y2 being the second point. In order to find the distance, we take the difference in x2 minus x1 and square it, and add it to the difference in y2 minus y1 squared, and then we take the square root of whatever number we get. So they ask us to find the distance between these 2 points, which means we just plug them in. So here's our x2, 1 minus 2, which is our x1. That quantity squared ends up being a negative 1 squared, plus a negative 4, which is our y2, minus a negative 5, which is our y1. That quantity squared, well, if we have a negative 4 plus 5, we have 1, and it, of course, is squared. So now we're left with 1 plus 1 squared. So the distance between those 2 points is simply the square root of 2. Now we're looking at something different yet. It's the midpoint between 2 points. It's the same idea, the x1, y1, and x2, y2. So to find the midpoint of these 2 points, we simply add x1 and x2. So there's the negative 3 and there's the 1. A negative 3 plus 1 is a negative 2 divided by 2 is a negative 1. Then we go over to the y and we have 3 plus 0 divided by 2, which is 3/2. So the midpoint between those 2 points is at a negative 1 and 3/2.